Welcome back, 8th grade. I hope your vacation was nice. LEAP is only 5 days away. So let's get into this Earth Science review and take a look at your last quiz before we move on. First thing we need to note is that the sun's rays hit the Earth at different angles. This is what leads to the uneven heating of the Earth's surface. If we take a little bit closer look at that, we see that Earth's rays are hitting a nice direct high angle at the center of the Earth near the equator. So those places are getting lots of sunlight, longer days, and warmer temperatures. The further away from the equator we go, north or south, we're getting those lower angles over a larger area, and we're getting cooler air temperatures. That uneven heating of the Earth's surface is what gives us our weather. So when we talk about types of weather around the globe, we're talking about how the sun's rays unequally heat the Earth's surface in different areas. Those 4 types of air masses that we get from that weather is continental, which is our land, maritime, which is water, polar is cold, and tropical is warm. So if we're looking up here in North America, the continental polar air is coming from an area that is just land, nice and dry air, and it is polar because it's coming from that north region where the unequal heating of the sun's rays cause those lower temperatures. So continental polar. The opposite would be true for maritime tropical. Maritime is our water. Tropical is near the equator, so those direct sunlight, that direct ray from the sun is heating up the water nice and warm, so we get tropical weather from there. 3 parts of the water cycle which are really important and really confusing. Let's know the difference. Evaporation is when the sun rays heat up the water and causes it to turn from liquid into vapor. Condensation is when that water vapor collects together and forms those clouds. And then precipitation is when those heavy clouds get so heavy they have to return back to Earth into a liquid or solid state. Alright, then we look at how the seasons form. It's because of the Earth's tilt on its own axis. So as it rotates on its own axis, it is tilted a certain degrees, about 23 degrees. So when the northern hemisphere is tilted towards the sun, we get summer. When the northern hemisphere is tilted away from the sun, we get winter. The same is true, but in the opposite way for the southern hemisphere. Alright, we need to know the difference between rotation and revolution. Rotation is 1 day on our own axis. That's when the Earth is just rotating on its own axis in one full circle. That takes 24 hours, 1 day. Revolution is 1 full year around the sun. So the Earth revolves around the sun, makes one big circle, takes 12 months or 1 year to get all the way around. Alright, knowing the different lunar phases, the 2 most important being new moon versus full moon. A new moon is when we can't see anything because the sun is behind the moon. That's when the Earth is first, then moon, then sun. We can't see the sun's rays because it's on the other side of the moon, so we get a new moon. The full moon is when we go full moon first, then Earth, then sun. We see the full moon because we see all of that light ray reflecting off the moon's surface and coming back to Earth to show us the full moon. We need to know solar versus lunar eclipse. A solar eclipse can only happen in a new moon phase because the moon is in between the Earth and the sun. A lunar eclipse can only happen in a full moon phase because the moon is on the opposite side of the Earth from the sun. Need to know the difference between troposphere and stratosphere. Troposphere is the closest layer to the Earth, and that is where all of our weather occurs. Stratosphere is next. That's where our ozone layer is. That's where the sun's rays get trapped, bounce back to Earth, causes that wonderful greenhouse effect, which we really like. But too much of that traps carbon dioxide and other greenhouse gases, leading to global warming. First troposphere, then stratosphere. Stratosphere is where we find the ozone layer. Talking about convection currents, just know warm air rises, cool air sinks. Warm air rises, cool air sinks. That's what we see in sea breeze and land breeze. Sea breeze is when the air rises over the hot land and sinks over the cool ocean. Land breeze. Air rises over the hot ocean, sinks over the cool land. It moves in a cycle. It's named for the place that the cool air moves from. Convection currents. Know that word, convection. Warm air rises from the heat in the inner core, causes tectonic plates to move. So we see convection currents inside of the Earth, outside of the Earth, in our houses, in our cars. Anytime you have warm air rising and cool air sinking, we're looking at convection currents. Then we look at the way the Earth is lined up. We've got the crust on the outside, that's where we live, then the mantle, that's the largest part of the Earth, the outer core, and then the inner core. We take a look at how those are different from each other. Continental plate is what's resting on the outside. The mantle is kind of like a semi-liquid flow, if you were to imagine the way the asphalt on the road would move on a hot day. That's how the mantle flows, really slow. Outer core is liquid and inner core is solid. Then we look at the way the plates move on that mantle. So divergent plates are the ones that are pulling apart. Seafloor spreading is happening when these plates are pulling apart. Rift valleys are formed from those seafloor spreadings. And the Mid-Atlantic Ridge is the best example of divergent boundary. Convergent is when those plates push together. There's a subduction zone that forms. So a subduction zone is anytime one convergent plate is going underneath another one. So we get three different kinds: ocean to ocean, ocean to land, and land to land. Land to land is when we get our mountains forming. Then we talk about, how do we know that these plates are moving? How do we know that continental drift is a real thing? Fossil evidence is our biggest clue, the biggest proof we have. If you look at South America, Africa, India, Antarctica, and Australia, all of them are showing that this fossil fern used to live there. But we all know that Antarctica doesn't have any plants growing on it today, so it must have been in a different place at some other time where this fossil fern would have grown on all of the continents. That's how we know continental drift is a real thing. We look at the three different kinds of rocks that form. Sedimentary is when weathering and erosion happens to any of the types of rocks. Igneous, coming from the inside of the earth, coming out through a volcanic explosion, is when those rocks get melted and then cool. And metamorphic, metamorphosis meaning change, is when we get heat and pressure, lots of it, applied to these types of rocks and turns it from one type of rock into another. Then we look at our inner planet versus our outer planet. Just remember, my very educated mother just served us nachos. That will help you remember the order of the planets. The inner planets are dense, they're small, and they're terrestrial, meaning there's land. Our outer planets are less dense, they're huge, and they're gaseous, meaning there's no land. There's just lots and lots of layers of atmosphere. They're divided by the asteroid belt. Inner planets are closer to the sun. Outer planets are really far away from the sun. So that wraps up our Earth Science review. Now let's see if you can answer those questions and compare them to how you did on your last quiz. Good luck!